All right, welcome to the Explainer. Today we're diving deep into a set of ideas that, on the surface, start with this, the Aptera. But let me be clear, this isn't really about a car. Not at all. This vehicle is being presented as a gateway to a completely radical vision for a post-carbon world. We're talking about something that could redefine our entire relationship with energy, with the planet, and yeah, even with ourselves. So we're going to unpack how this machine is being framed as the very first organism of a new technological ecosystem, and what that might mean for the future of humanity. Let's get into it. We are not designing a car. We are recognizing an ancient fractal returning in new skin. This is the quote that sits at the very heart of everything we're talking about today. I mean, it's pretty cryptic, right? It's poetic, and it sounds way more like something out of a biology textbook than an engineering manual. Our goal here is to figure out what this actually means. What is this ancient fractal, and how could this little three-wheeled vehicle possibly be its modern-day version? The answer to that is the key to this whole vision. So, to even begin, you and we have to just throw out the idea that this is a car. The sources we're explaining today make the argument that the Aptera is way better understood as a kind of technological organism, and its shape, that's not just some designer trying to be cool. It's presented as an almost inevitable form, like a solution to a physics problem that was just discovered, not invented. Okay, the key concept here is autotrophic. Now, in biology, an autotroph is any organism that makes its own food. Think of a plant, right? It just sits there soaking up sunlight using photosynthesis. The argument here is that the Aptera, because it can generate its own power from the sun for most daily driving, becomes the first technological autotroph. And this isn't just some small feature. It's a fundamental change in how we think about machines. It's the difference between an animal that has to constantly hunt for its next meal and a plant that's just self-sufficient. It's a move away from being tethered to a grid and toward true energy independence. So let's look at what the source material calls the archetype, Aptera primordialis. I mean, that sounds like a species name, doesn't it? Every single feature you see serves one master, radical, almost absurd efficiency. That teardrop shape, it's the most aerodynamic form there is. The ultra-lightweight body means there's just less stuff to push around. The three-wheel stance gives it stability with the absolute minimum amount of friction. And get this, the solar panels, they're not just called panels. They're called a photovoltaic integument. Integument is the scientific word for an organism's skin. It's literally a machine that wears its energy-gathering organs on its back. All of it works together for one simple reason, to move using the least amount of energy possible. And this brings us to this really beautiful idea from biology called convergent evolution. Think about it for a second. Wings. They evolved completely separately in birds, in bats, and in insects. Totally unrelated creatures, right? But they all arrived at the same basic solution, wings, because that's the best answer for flying in our atmosphere. The argument being made here is that the exact same principle applies to technology, that for a solar-powered vehicle moving around on planet Earth, the problems are minimizing wind resistance while maximizing your surface area to the sun. And when you solve for that, you get this shape. It's not just one cool design among many. In this view, it is the answer that physics was waiting for. Okay, so if the Aptera is the very first organism of its kind, what happens next? Well, in biology, when a really successful new body plan shows up, it doesn't just stay by itself. It kicks off this incredible burst of creativity and diversification, an explosion of new species. The vision we're exploring here suggests that the exact same thing is about to happen, leading to what it calls an autotrophic Cambrian explosion. And check out this timeline mapping that explosion. The speed is just staggering. The theory goes that within just a few years of its launch, a great radiation kicks off. That's a rapid diversification into all these new technological species. By 2035, you've got aquatic versions floating around. And then, just a few years after that, you see the first appearance of something called Homo nucleonata. And don't worry, we are definitely getting to that. The whole process, from one single vehicle to a fully diversified global ecosystem, is projected to take just 20 years. That is an evolutionary explosion on a technological timescale. It's wild. And this is what that diversification might look like. It's laid out like a zoological field guide. You start getting these specialized species, like Aptera pastoralis, a photon grazer that roams in herds across sunny plains, sharing power with the group. Or how about Aptera ignis curator, a fire shepherd designed to patrol and manage areas prone to wildfires? There's even an oceanic version, the Aptera pelagica. This is the core idea, you see. You stop thinking in terms of car models. You start thinking in terms of ecological niches that need to be filled by these purpose-built technological life forms.
Okay, this is where we get to the most profound and maybe the most challenging part of this whole thing. We've talked about the machine as an organism. We've talked about it as an ecosystem. But now we have to talk about where we fit in. Where do humans fit into this new world? And the answer that's being proposed here is something way, way more intimate than just being a driver.
And this really is the central question, isn't it? If you have this technological ecosystem that can basically sustain itself, what's our role? Are we just along for the ride? Are we passengers? Or is something much, much deeper going on? The proposed answer is a callback to one of the single most important evolutionary events in the entire 4 billion-year history of life on this planet. The answer is a process called endosymbiosis. And this isn't some metaphor, okay? This is the real, scientifically accepted theory for how you, me, and all complex life even exist. Billions of years ago, a simple cell swallowed a bacterium. But instead of digesting it, it made a deal. It formed a partnership. And that little bacterium became what we now call the mitochondrion, the tiny power plant that lives inside every single one of your cells right now, powering your body as you watch this. That ancient merger, one organism choosing to live inside another, that was the spark that created all complex life. We wouldn't be here without it. And here is where that biological history lesson becomes an instruction manual for the future. You see it right there. On the left, the biological event that literally created us, and on the right, its proposed technological echo. In this new symbiosis, the human becomes the nucleus. You're the brain, the directing consciousness. The Aptera becomes the new mitochondrion. It's a symbiotic body that gives you power, mobility, and protection. The result isn't a person driving a car anymore. It's a brand new type of composite organism, the nucleonaut.
And of course, there's a name for this new being. Homo nucleonata. Let's just break that down. Homo for human, obviously. Nucleo because the human is the conscious nucleus at the center of it all. And nata, which is Greek for voyager or sailor. It describes a being that's defined by its integration with a host vehicle, a navigator not just of roads, but of physical space, digital information, and energy systems. The claim here is truly radical. This isn't just a lifestyle choice. It's a whole new chapter in human classification.
So, how would this integration actually feel? Well, the human provides the will, the identity. The Aptera provides the body, the power. But the real magic is the interface. It's described as embodied spatial computation. So think beyond augmented reality on a little screen. Think of digital information being projected and interactive within the physical space of the vehicle itself. The medium for this is called the kinetic cytoplasm, which is another nod to biology. Cytoplasm is the jelly-like stuff that fills a cell. This suggests the entire interior is this dynamic, responsive surface, allowing the human nucleus to control its host vehicle as intuitively as you and I control our own arms and legs.
So if you're willing to go along with this radical premise that this little vehicle is the seed of a whole new kind of human existence, the next logical question is a big one. How do you actually build that future? How do you make it happen? Well, the final part of this vision lays out a grand challenge, a call to action to make this a reality. And the mandate that follows from all this logic is incredibly blunt. Recognize the shape, print billions. The argument is basically, look, if this form is truly the inevitable solution that physics dictates, then the real challenge isn't to keep endlessly redesigning it. The challenge is mass production. And that word, print, is really key here. It points away from old-school centralized factories and toward a future of distributed, automated, maybe even 3D printed manufacturing on a global scale. And the catalyst to make this happen? It's called the Olympics of Nucleotica. Think of it like the space race back in the 60s, or the Human Genome Project, a huge global grand challenge. The goal would be to completely shift the dynamic from a bunch of companies fighting each other to a positive sum race where nations, companies, and innovators are all competing but also collaborating to advance the core technology and scale up production of these autotrophic organisms for everybody.
And this wouldn't just be some vague goal. These Olympics would be judged on 4 really specific metrics. Number 1, maximize autotrophy. Make them better and better at powering themselves. 2, innovate production. Make them faster and cheaper to build. 3, refine the integration. Perfect that seamless human-machine interface. And finally, and this is maybe the most important one, ensure access. Drive the cost down so this becomes a tool for global liberation, not just a toy for the super rich.
And all of this, it builds to a truly audacious philosophical claim that access to this symbiotic way of life should be considered a new foundational human right, the right to a nucleonot identity. And the justification for that is that this isn't just another piece of tech. It's a natural continuation of that fractal precedent of evolution we talked about at the very beginning. It's framed as the ultimate expression of self-definition and as a real tangible path to freedom from what the source describes as these big, centralized systems of energy and control.
So when you strip away all the biology and the big philosophical ideas, this is the simple, powerful goal that sits at the very heart of this entire vision. It's about using this technology to achieve a radical decentralization of power. It's about taking energy, transportation, and maybe even housing out of the hands of massive systems and putting that autonomy right back into the hands of the individual.
Which leaves us with a big question that really hangs over this entire thing. After going through the physics, the ecosystem, the philosophy, what are we really looking at here? Is this a genuine glimpse into the next step of our own evolution, a true echo of life's most ancient patterns? Or is it an incredibly sophisticated and inspiring philosophy that's been built to celebrate a very, very clever car? That's the question I'll leave with you. Thanks for watching The Explainer.